Hey, today I want to talk to you about a type that is a little bit more advanced, but that is a big unlock for a lot of the more scary types that you see in third-party libraries, and some of the mechanisms you see there. That is conditional types, indexed lookups, mapped types, and also the infamous never keyword in TypeScript. Is super helpful for types that you see in the wild. For example, React has this type called element type, and of course the definition is very long and scary, but in its essence it just helps you to find props for native DOM elements such as anchor tags or div, or work with these native elements, with the types of the native elements in a structured way. And for me, at least, it was a super big unlock to understand this type filter conditionally, because there's specifically one mechanism in there that looks scary, but once you understand it, it's a big unlock for a lot of these like large and scary types that you see in the wild. So what does filter conditionally do? Let's pull up an example here. Let's say we have an object-based type that is called sample, and sample is an object-based type. It has 4 properties, 2 of type string and then number and boolean. And now we want to filter this type sample for properties that are of a specific type. So here we want to filter this object for everything that is of type string. So naturally what is left after applying this type is property 1 and property 2. But we could also exchange this for a number here. And then what would be left is only property 3. And this works for all sorts of types. This also works for object-based types or any sort of type you can come up with. But how does this type actually work? Let's build it from scratch so we understand it. Let's keep the sample object-based type here that is our source. And let's pretend for a moment we want to do the exact same thing we did in the beginning, where we wanted to filter this sample interface here for properties that are of type string. If we wouldn't try to do this in a automated or a dynamic way, it would be pretty easy. We would have a type called result, and this would use this utility type called pick, and as a source object we use a sample, and then we would just go property 1, property 2. If you're a bit unfamiliar with this pick type, there's always great resources on the official TypeScript websites on how these utility types work. Here we're just picking properties along with their types from an object-based type with the help of a union. And the result is the exact same we got from our finish type, filter conditionally. But of course, here we hard-coded our property names. There was no dark magic going on. We simply looked at the type and said, oh, we want an object-based type that has property 1 and property 2 along with their corresponding value types. So this is also the final shape that we want. We know we want to pick certain properties from our source object that is sample. But what we don't know is how do we achieve, or how do we get to this union of property names that meet our filtering condition, not in a hard-coded way, but in an automated way. And for this to work, I'll throw something on the page and explain it a bit later. So let me throw this on the page here. Let's say we call this new type here mark unwanted types as never. And this also has a generic like source and condition. And what this basically does, so let's maybe exchange the generics here to make it a bit more clear. Let's focus on generics later. Let's just call this sample, and let's also not say we have a generic condition here, but let's say we really want to just filter for everything that is a string. So we can look at generics at the very end. So here this type really just tries to apply a filter condition to the sample object for every type of value of type string. But how does it actually do this? It uses a mapped type, so we loop through every single property in this object here, and then we ask, is the value of this property, the corresponding value of type string, like a valid subtype of string? This could also be a string literal, but it needs to be a valid subtype. If it is a valid subtype, we want as the type for the value. We no longer in a new type want it to be like string. We put the literal string value of the key. So here, property 1, this key. So we map through every key. We take the literal string value property 1 as the value of as a type of the value here. And if it isn't a valid subtype of string, we put never here. And this is the trick that you see in a lot of complicated types in the wild as well, because this allows us to filter. It's a bit abstract at first, but once you mastered it, it will come way more naturally to you. So let's look at the example. What does this new type actually produce? I'm copying it out here because in a minute we'll adjust it slightly and then this output will go away. So as I said earlier, we loop through every key and then we put the literal string value of the key as the value if it meets this filtering condition here. And if it doesn't, we put never. And what is the goal here? Why do we do this? This seems a bit counterintuitive, like an unnecessary step. The goal here is, with a very simple trick, we can create a union of the value types here. We can create a union, and in this union, when we have a union, this is what we want to end up with. We want to end up with a union of property 1, property 2, and then we're just using all the values here. So we have never, never. And if we create a union out of these types, the never types will disappear because a union will just try to combine the two or the sets, all the sets in a union. And the never value is an empty set. So it won't have any effect on the size of the corresponding set that is the type we come up with. So what you need to take away from it here is that when you have a union and one member of the union is of type never, it will not be included in the union. It will just be filtered out just automatically by Typescript because a never is an empty set. So it has no effect on the union that we're forming here. So the result would just be property 1, property 2, if we put all the value types here in a union. The question still is, how do we get a union out of all the values here? And if you're a bit advanced in TypeScript, you already know how this works, but we can simply use a key of sample here. And this will create another union. This will just as regular JavaScript where you try to do an index lookup right into an object. You can just say here, we're doing an index lookup, but not with just one value because we're dealing with types here. But you wanted this index value, this index lookup, you wanted to have it with a union out of all the names or the literal like keys for this object-based type. So what key of sample does is nothing else than if you expand it, it's nothing else than a union of property 2, property 3, and so on. This is the exact same that just key of sample. It's the exact same that key of sample does. So what we get back, if we iterate through just all the values here, because we're using all the keys, that means we get a union out of all the values, but we drop the never values because they're empty sets. And what we get in the end is exactly what we want. We want a union from these properties that meet our filtering condition. This was the part that we wanted to generate programmatically, and this is how we did it. And the last step that we need is just to pull these two types together and come up with a new type definition that combines these two types that we have. So we need to just use the pick add to generics first, but then we need to use the pick on the source object, and then enter this type where a hard-coded union is to generate the union that we need to dynamically get the filtered property names. And this is the result. This is the final type we had at the very beginning of this video. This is the result. This is the final version of the type. And understanding this type, especially the trick where you set the type for the value as the key to then create a union that filters out all the never values, is super valuable to understand a lot of these scary long form type definitions that you see in third parties. I hope this was valuable to you. Feel free to rewatch this video if it was a bit too abstract, or leave a comment or a note, and I'll try to explain it as best as I can. If you found any value in this video, leave a like, and see you in the next one.